Like referring to stupid.
S-T-O-O-P-S.
No! I'm so confused. No.
It's on the recording. You can. It's official if this is working, which I think it is. All right. I think the sound quality will be a lot better with this thing. We'll find out. I've got 3 problems I'd like to go through with you. Dealing with, notice we skipped a section. We went from inverse functions, which was 4.5. We skipped 4.6. And 4.7 is word problems, basically is what it is. But we're going to form functions from a verbal description, which basically means you got a word problem. So the objective is to form a function of one variable from a verbal description, and when appropriate, determine the max or min. So that's the bottom line, you guys. And when it says when appropriate, I would say most of the time, our job is to find a max or min. We're probably going to need technology, unless it's a quadratic. If it's a quadratic, why do we not need to use technology? What's the best way to find it? Find a max or a min. Negative b over 2a. Opposite of b over 2a finds the axis of symmetry, tells you the max, it tells you where the max or min will occur. Plug it in, you'll find out what it is. If it's a cubic, we're going to need to use technology. I have 3 examples I'd like to go through with you. And I think they kind of cover different parts. And as we go, I need to throw some formulas at you that you probably have seen and should know. Okay, like the volume of a box, like the volume of a cone, like the volume of a can, like the surface area of a sphere, like the area of a triangle, like the Pythagorean theorem. A squared plus b squared equals c squared, right? Those kinds of things. So as we go, I'll throw them out at you. The first example says this. An open top box with a square base. First thing you want to read there. Sorry. There's not enough plugins in this room. I need an extension. The first thing I want you to recognize when you see this is, I know you should read it through, read it more than once, but right away you have an open top. No top on the box. Square base is to be constructed from sheet metal in such a way that the completed box is made of 2 square meters of sheet metal. The reason it's open top, that should tell you something, right? When we talk about the surface area, there's no top to worry about. So I think drawing a picture helps. And I'm not great at drawing these, but you don't have to be great. Just be good enough. Draw some type of shape that looks like a box. And it tells me that the box has a square base. Since it has a square base, I know that the 2 sides are exactly the same. I'm preferential to x, so I'm going to call them both x. What should I call the height? Well, normally we call it h, right? We might have length, width, and height, but in this case, since the base is square, I would use an x and an x. So I know this. I know that the volume of this box is going to be x squared times h. The area of the base, the volume of anything that goes straight up, so we call that a prism, is big B times h, where big B is the area of the base. So it could be a triangular prism in this case. It's a rectangular prism. It's a box. Now I have volume in terms of x's and h's. That's why you need another formula, another equation, so we can do some substitution to get rid of one of the letters. And we can do that because they tell us that the surface area is 2 square meters. So I know that the surface area of this box would be x squared plus 4xh. Take a second and process that. Do you agree with me? And why could I do it that fast? I hope you could do it that fast as well. But the bottom is x squared. There is no top. Otherwise, it would be 2x squared. Why 4xh? Why 4xh? There's 4 sides, number 1. And would you agree that all 4 sides have the same area? Dimension 1 times dimension 2, x times h. So you have the 4 sides going around. I'm not very good at shading that, but this side back here, of course, is the same as this side right here. X times h. We have 4xh. They tell us that the area is 2. So I know that x squared plus 4xh has to equal 2. That's the second piece that I have to know. The goal is to find the volume, of the box in terms of the base width. And my question then, I have an x there. My goal is to find what's the volume in terms of x. If you're trying to find the volume in terms of x, that means I need to get rid of that h. But luckily, I can, because right here is an h. I should be able to solve that equation over here, this one, for h. So we isolate what term has the h. So I have 4xh equals, I'll write it this way. You could write it either way, 2 minus x squared. So h is 2 minus x squared divided by the quantity 4x. Does that make sense to everybody? I just solved that formula for h. Technically, that's h in terms of x. Really what we're doing is a composite. I'm going to take this now, right here, and I'm going to replace that h right there. So I'll have x squared, and if I replace that h, I'll have 2 minus x squared in the numerator. In the denominator, I have 4x. We probably should go another step and clean that up a little bit. You've got an x squared in the numerator, you've got a 4x in the denominator. If I clean that up a little bit, I'll have something like this. X times 2 minus x squared, all over 4. I have written the formula, a formula for the volume of my box. It's based on initial information that says it's made of 2 square meters. So if you have a different box, it's made of a different amount, we'd have a problem, but there it is. That's the volume of the box. This one we don't have to maximize or minimize. We just wanted to find the volume of the box in terms of the base width. My base width is x. So you take 2 equations, substitute. Let's try another one. This one says this: a north-south path intersects an east-west river at point 0. At noon, a horse and rider leave point 0, traveling 12 kilometers per hour. At the same time, a boat is 25 kilometers east of O, traveling west at 16 kilometers per hour. I think it's really important to get some type of a picture. Okay, so here's my path, and here's my river. That's why I'm not an art teacher. You guys see the river? You see the path. Okay. Just like the x-axis and the y-axis, right? There's my path. We know our directions. That's probably another thing we need to talk about on a problem like this. Do we know our directions? North, never, eat, soggy, waffles. Thought it was shredded wheat. Soggy waffles.
What did
Okay.
your mother eat?
So what do we have? Here's my point 0 right there. So I've got a horse and a rider that are going which way? They're leaving 0 and they're going north. Does it tell us that?
12. Yeah.
It doesn't tell us that.
Of course.
I'm gonna make. I must have missed it when I was typing in. We want them to travel north. So I've got a horse going this way. I've got a boat that's sitting out here, and it's traveling this way. Make sense with my picture so far? How far away is the boat out here? 25 kilometers. So the boat is sitting out there at 25 kilometers. The horse took off and is going this way, and it started right there. The question is this: express the distance between the horse and the boat. So, I mean, as the horse goes this way, the boat's coming this way. So I'm just going to stop at this moment in time, and I'm going to draw this in there. That's what I'm after. That's what we're going to call our D, is this right there. That's D, the distance between the boat and the horse. And we want to express that as a function of time, T, in hours after noon. I hope that you recognize what I have right here is what? What do we have right there? A right triangle. And anytime you have a right triangle, I hope you recognize and remember the Pythagorean theorem. So that means whatever this side is squared, this side squared equals the hypotenuse squared. We don't have anything written though for this side right here. So to write something for that side, we have to think back to another formula that you should have in your back pocket somewhere, and that is distance. What does distance equal?
square root of x squared minus x1 second plus y squared minus y squared minus y. If I could write it up on the board, it'd be easier to integrate.
That was over my head. How about, let's back up. We're going to go there, but we're not ready to go there yet. The question is, what does distance equal? If you're driving a car and somebody says, how far are you going to go? How do you find out how far you're going to go? How far do you go depends on two things. What are the two things it depends on?
Speed of time.
It depends on your speed and your time. You drive 60 miles per hour, you drive for 3 hours, you've traveled 180 miles. You walk at 5 miles per hour and you do it for 30 minutes, how far do you go? Multiply by a half, right? 5 times a half, 2.5. So distance is rate times time. So let's make sure we write that one down somewhere. You're going to need that one. Distance is rate times time. And of course, rate and time have to kind of go together. We also said if we had a right triangle, if this side is A and this is B and this is C, we also have a formula that says A squared plus B squared equals C squared. Those are the two things we need to do to solve, or know to solve this problem. So if the horse is riding at 12 kilometers per hour, is that fast or slow? How many miles per hour is that? I should never ask a question I don't know the answer to. Sounds like science class. 1.61 kilometers in a mile. Would it be faster than 12 or slower than 12? It'd be slower, I think, right? Think about your speedometer in your car. 60 miles per hour equals 100 kilometers per hour. Something like that. When you drive to Canada, you gotta watch it. Look at the other gauge. 7.45 miles per hour. Okay, I can buy that. Is that fast? How fast can you walk? You get on a treadmill, how fast do you walk? 3 to 4. 5 if you're a good fast walker. 3 is pretty slow, kind of grandma style. Okay. So what we have on this one right here is the distance would be 12t. 12 times t. Just like if you're driving a car, it might be 60 times t. Or if you're walking, it would have been 5 times t. In this case, it's 12 times t. The boat is a little harder. Not a lot, but a little bit. What would be that red side on that triangle where the boat is? This is where the boat was, and this is where the boat is at the moment in time I'm talking about. Likewise, this is where the horse is at the moment in time I'm talking about. This distance is given to us as what? How fast is the boat going?
16 kilometers.
16. So this is 16t. That's not what we want, though. What do we want? We want that distance inside that triangle. How far is that? That whole thing is 25, so this has to be 25 minus 16t. Think about that a second. We're now ready to write an equation for the distance. The distance in terms of t. We want to know this side of the triangle. Does everybody know why I'm going to need a square root? A squared plus b squared equals c squared. I don't want the distance squared, I want the distance. So I'm going to do a square root. And now I'm going to worry about the a and the b over here, which in this case would be 12t, the quantity squared, plus the quantity 25 minus 16t, quantity squared. And because I don't have to, I'm not going to expand that. I'm going to say that's my answer. That is a formula. If you had 1 hour, plug it into your formula, you could know how far apart the boat and the horse are. If you did it at 2 hours, you could find out how far the boat and the horse are apart. I think we should take a second and actually find out when they are the closest. Using technology, when are they the closest? Let's try it on our graphing calculators. I'm going to need a little help because I probably won't remember. Well, I can type it in right now, I guess. So I would type in I'll move mine over here in just a second. But I'm going to need the square root of the quantity. Does that look right, you guys? Is that what you have? Square root, 12x squared, quantity squared, 20. Oh, did I miss one right here? I need this right here. I needed that squared, didn't I? But not this squared.
Yeah, you have x squared squared
Oh, I don't want that.
on the 12x.
So I want 12x, the quantity squared. And down here I had it right, and I changed it. I want that gone, and I want to insert squared right there. Whoops. Does that look better? Have my parentheses right? All right, let's graph this thing. But before I graph it, let's look at our window. What are we interested in? My x's. That's my time. I'm going to start it out at 0. And this is in hours, afternoon. I don't really know. Should we go 5 hours and see where we end up? We'll go by ones. My y, that's the distance between the horse. And I know that they're 23 apart right away. Of course, men, I don't really want it to be negative, so I'll probably say 0. And my y, maybe 23. I could have also said zoom fit on 0 to 5. But I think we'll go this way and we'll adjust as needed. Okay, so let's see what we have. And what were we interested in? When the horse and the boat are the closest, which would be the minimum of that curve. So let's find the minimum of that curve. So let's calculate a minimum. If I'm going too fast, let me know. You can either hold the arrow keys down. And if you're like me, that's kind of slow. I don't like doing that. But now that I found my spider, I'll do that. Hit enter. You can just type in a number if you want. Or hold your arrow key down until you move it around to the other side. Hit enter a couple times. That would tell me that at 1 hour, in other words, at 1 p.m., because it's hours afternoon, when x is 1, y is 15, and that's my distance. So the distance between the two are closest at 1 p.m. Make sense? They're closest at 1 p.m. Okay? Let's move on and do the last one. So that one, that's a good problem for you to think about because it involves distance formula, it involves right triangles. First one dealt with volume and area. And then the third one I think is going to deal with volume also, but the shape is different. And the third example deals with a cone. It says water flows into a conical tank 100 centimeters wide, that's the diameter, 250 centimeters deep at a rate of 40 cubic centimeters per second. Find the volume of the water in the tank as a function of the height h of the water. Represent h as a function of time t that the water has been flowing into the empty tank. So let's first of all get a sketch of what this tank is going to look like. So I've got a cone. I guess I probably made it a little bit too wide on the top, but that's all right. There's my cone. And water is going to flow into this cone, so I'm just going to mark where I think the water is after a certain amount of time. I'm going to label a couple other things. I'm going to label the radius right here. If the diameter is 100 centimeters, then this is 50 centimeters. And the height is 250 centimeters. So I'm going to label that. Something like that. 250 centimeters. Anytime you work with a cone, before I even get any further into this, some of you are going to take calculus next year. Anytime you work with a cone, always think about this. Similar triangles. Always think about similar triangles. So I'm going to write it down before we even start. Remember similar triangles, same shape, different size from your geometry class? So what we're going to have is something like this. I'm going to run this right down the middle because that's my height. And I'm going to call this the radius of my water level. Maybe I should switch colors there. This will be the radius of my water level. And this is going to be the height of my water level. Do you see the similar triangle? Before I even get started to write down any formulas. Because this is the part that trips everybody up when you work with cones. Always. It's always similar triangles. This is the part they forget. Let's talk about where they are. This triangle right here. Everybody see that triangle right there? I'm not going to go through why they're similar, but they share a couple angles. This angle is going to be the same here, and that angle down there is the same. So angle, I think is what you call that. The other triangle is right here. Let's do this one in this triangle right here. There's the big triangle. And the small one, right there. Okay? That's the key to doing this problem. Now, let's go back and let's write down some formulas that we should know. Volume of a cone, volume of a cone, volume of a cylinder is pi r squared h, but if it's a cone, all you need to do is divide it by 3. So either you divide by 3, or some people have learned you put 1/3 in the front. Multiplying by a third, dividing by 3, the exact same thing. So that's a formula that I need. This formula is in terms of r and h. Has nothing to do with time. Because it tells us to represent h, the height, in terms of time. But before we do that, it does tell us up here to find the volume as a function of h. Find the volume as a function of h. That means I need to get rid of the r. Yep, I need r in terms of h is what I need. Back to now similar triangles. Big is to small as big is to small. That's how I like to do it. Or one side to the other side. The other, I don't know which way you guys like to do it. You guys got to help me. You want me to write r is to 50 as h is to 250. Or do you want me to write r is to h as 50 is to 250? And then my second question is, does it matter? I'm asking your opinion which one you want, but I think it doesn't matter because when you cross multiply, do you get the exact same thing? When you cross multiply, you will get the exact same thing. So I don't care which one you do. One side to the other side, small to big, or small, small to big, big. Your choice. When you cross multiply, either way, you're going to get 250r equals 50h. Which letter did I say we wanted to get rid of? We wanted to get rid of r. Up here, we wanted to get rid of r. So let's solve this for r. So here's our second equation, in other words. So r will equal 50h divided by 250. If you simplify that, you get h over 5. So now I'm going to replace the r up above with that. So then I'm going to have 1/3 pi. In place of r, I'm going to have h over 5. Remember to square it, times h. I now have volume written in terms of h. I have a formula that if I know where the water level is, if I know if I had to stick down the middle of this cone, whatever the height is, if I can measure it, this is the formula that will give me the volume, granted that I know what the height is. Let's clean this up a little bit. So the volume in terms of h would be, can you guys do this in your head? H cubed, h squared times h in the numerator. I'm also going to have a pi in the numerator. And in the denominator, I'm going to have a 25 and a 3, which is 75. So there is a formula of the volume in terms of h. So if you had some type of measuring stick, you can determine the volume based on what the height is of the water. That's the first part. So there's my volume in terms of h. I've done that. Now, the second part's a little harder. It says write h as a function of time. So if you had a stopwatch and you know that the water is being dumped in there at a certain rate, and they tell us the rate right here is at 40 cubic centimeters per second. I don't know if we can think about how much that is. A cubic centimeter? Does anybody know another name for a cubic centimeter from your science class? Milliliter. A milliliter. So you're doing 40 milliliters per second. How many milliliters in a can of pop? Or how many, can't do can of pop anymore. We gotta use water bottles because everybody drinks water, right? You're all healthy. How many milliliters in that, Riley?
700.
Smart water. Not a half a liter. It's 7/10 of a liter, huh? 700 milliliters. So how long would it take to dump that water bottle out if we did 40? What do we say? 40 milliliters a second? We can kind of visualize that this water is not being dumped in there very fast, right? Not a real fast rate. Okay? So, we want to know what's the height of the water as a function of time. This is tough, you guys. This part, second part of this problem is tough. Just like we did with the cars, or the horse and the boat, we know that the volume can be thought of as a rate problem. And the rate problem being this, 40 times time. You know how much water is in the tank based on how fast it's being poured in. 40 times T. Rate times time. Rate is 40 times T. That's a formula, volume in terms of T. Volume equals this. Well, if volume equals this, and volume equals this, what can you conclude about the two things in green? They're equal to each other. So we know that pi h cubed over 75 equals 40 times t. We know that they're equal to each other. Which letter do I want to solve for if it says represent h as a function of time? I want to solve for h. A little bit hard to solve this one for h. I'll do it in 2 steps. So this would say that h cubed equals, I need a little help. We're going to multiply by 75. So what's 75 times 40? How much? 3,000? 3,000 t. And then I'm going to divide by pi. What's my last step? So I can write h as a function of t. I'm going to do the cube root. I'm going to do the cube root. So h would equal the cube root of 3,000 t divided by pi. That's h. That's h as a function of time. So again, if you have a stopwatch and you did it for 10 seconds, if you plug it into this formula, you know how deep the water is. If you did it for 20 seconds, this formula gives us how deep the water is. That's kind of hard. I would kind of keep that one in my notes to look back at. I'm done talking. I took all your time again, didn't I? Sorry. To make this problem a little more interesting, you drip water out of the bottom. And then you get into calculus. Not only do you put water in, but you take a little bit of water out. And what we're interested in calculus is, tell me about how the water level is dropping here versus here versus here. And you've all done this because you've all probably played a game where you have that hourglass and you flip it over. It's got sand in it. What game would that be? Pictionary. So you take that little timer and you flip it. You've all done this before. You see the sand in there and it drops. Tell me about how the sand, or in this case, how the water level is dropping at this point versus this point. Versus this point. What's happening to the water level? What's happening to the sand as you move down? It disappears quite fast, doesn't it? That's the good stuff. I don't want to give away anything else on calculus, but come back next year. Okay, here's the plan. Here's the plan. We're going to work on these problems. This is going to take us a little while. And because of the musical, I'm going to give you tomorrow to work on that. And I'm going to give you Friday to work on that. Because I know we've got some people gone. And I don't want them to be distracted with pre-calculus when they have to remember their parts. And when to turn the lights on, and when to turn the mics on, and when to turn the mics off. So we're going to have Thursday and Friday to work on that. Now that means, here's the plan. If you get done with that, let's say Friday, you might want to work ahead. Because the last thing, all we have left to do is a chapter test. Minus the section, the question that might deal with the section we skipped, of course. What's next week?
Thanksgiving.
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 What does that mean? We're only going to school 3 days, right? So Monday, we'll make sure all your questions are answered from the review. I'm thinking we'll take the exam Tuesday. What does that mean Wednesday?
Monday.
Probably don't want to start another chapter on Wednesday, do I? But I also don't think I want to take the quiz. We could do it on Wednesday, but I'm thinking let's do it Tuesday because other teachers are probably going to nail you on Wednesday.
I think
I'm not sure. And then if anybody is gone or sick in this class, that never happens, but you'd have a day to make it up on Wednesday. So that's our plan. We'll wrap this chapter up before Thanksgiving.
Mr. Sherman, I think there is other update Thursday.
It's first time.
Oh, it is? Oh.
This one?
I don't know.
Chemistry.